The Buk missile system, Russian, beach, tree, /BK/, is a family of self-propelled, medium-range surface-to-air missile systems developed by the Soviet Union and its successor state, the Russian Federation, and designed to counter cruise missiles, smart bombs, fixed and rotary wing aircraft, and unmanned aerial vehicles. The Buk missile system is the successor to the NIIP/Vimpel 2K12 KUB, NATO reporting name SA-6 Gainful. The first version of Buk adopted into service carried the GRAU designation 9K37 and was identified in the West with the NATO reporting name Gadfly as well as the U.S. Department of Defense designation SA-11. With the integration of a new missile, the Buk M1-2 and Buk M2 systems also received a new NATO reporting name Grizzly and a new DOD designation SA-17. In 2013, the latest incarnation Buk M3 was scheduled for production. A naval version of the system, designed by Nir Altair, currently part of GSKB Almazantiy, for the Russian Navy, received the GRAU designation 3S90M1 and will be identified with the NATO reporting name Golem and a DOD designation SAN7C, according to Jane's Missiles and Rockets. The naval system was scheduled for delivery in 2014. Development of the 9K37 Buk started on January 17, 1972 at the request of the Central Committee of the CPSU. The development team included many of the same institutions that had developed the previous 2K12 KUB, NATO reporting name Gainful, SA-6, including the Tikhomarov Scientific Research Institute of Instrument Design, NIIP, as the lead designer and the Novator Design Bureau, which was responsible for the development of the missile armament. In addition to the land-based system, a marine system was to be produced for the Navy, the 3S-90 Uragan, Russian, Hurricane, which also carries the SAN-7 and Gadfly designations. The Buk missile system was designed to surpass the 2K12 KUB in all parameters, and its designers, including its chief designer Ardalian Rostov, visited Egypt in 1971 to see KUB in operation. Both the KUB and Buk used self-propelled launchers developed by Ardalian Rostov. As a result of this visit, the developers came to the conclusion that each Buk transporter erector launcher, TEL, should have its own fire control radar, rather than being reliant on one central radar for the whole system as in KUB. The result of this move from TEL to transporter erector launcher and radar, tailor, was development of a system able to shoot at multiple targets in multiple directions at the same time. In 1974 the developers determined that although the Buk missile system is the successor to the KUB missile system, both systems could share some interoperability. The result of this decision was the 9K37-1 Buk 1 system. Interoperability between Buk tailor and KUB TEL meant an increase in the number of fire control channels and available missiles for each system, as well as faster entry of Buk system components into service. The Buk 1 was adopted into service in 1978 following completion of state trials, while the complete Buk missile system was accepted into service in 1980 after state trials took place between 1977 and 1979. The naval variant of the 9K37 Buk, the 3S-90 Uragan, was developed by the Altair Design Bureau under the direction of Chief Designer G. N. Volgin. The 3S-90 used the same 9M38 missile as the 9K37, though the launcher and associated guidance radars were exchanged for naval variants. After the 9S-90 system was tested, between 1974 and 1976 on the Cushing-class destroyer PROV Orny, it was accepted into service in 1983 on the Project 956 Sovremenny-class destroyers. No sooner had the 9K37 Buk entered service than the Central Committee of the CPSU authorized the development of a modernized 9K37 which would become the 9K37M1 Buk M1, adopted into service in 1983. The modernization improved the performance of the system radars, its probability of kill and its resistance to electronic countermeasures, ECM. Additionally, a non-cooperative threat classification system was installed, relying on analysis of returned radar signals to purportedly identify and clearly distinguish civilian aircraft from potential military targets in the absence of IFF. Another modification to the Buk missile system was started in 1992 with work carried out between 1994 and 1997 to produce the 9K-37 M1-2 Buk M1-2, which entered service in 1998. This modification introduced a new missile, the 9M317, which offered greater kinematic performance over the previous 9M38, which could still be used by the Buk M1-2. Such sharing of the missile type caused a transition to a different GRAU designation, 9K317, which has been used independently for all later systems. The previous 9K37 series name was also preserved for the complex, as was the Buk name. The new missile, as well as a variety of other modifications, allowed the system to shoot down ballistic missiles and surface targets, as well as enlarging the performance and engagement envelope, zone of danger for potential attack, for more traditional targets like aircraft and helicopters. The 9K37 M1-2 Buk M1-2 also received a new NATO reporting name distinguishing it from previous generations of the Buk system. This new reporting name was the SA-17 Grizzly. The export version of the 9K37 M1-2 system is called Ural, Russian. This name has also been applied to M2, at least to early, Tod, export versions. The introduction of the 9K37 M1-2 system for the land forces also marked the introduction of a new naval variant, the ES, which carries the NATO reporting name SAN-7B Grizzly, 9M317 missile. Was exported under the name Stil and carries a NATO reporting name of SAN-7C Golem, 9M317E missile, according to Jane's catalog. The 9K317 incorporates the 9M317 missile to replace the 9M38 used by the previous system. A further development of the system was unveiled as a concept at Euronaval 2004, a vertical launch variant of the 9M317, the 9M317Me, which is expected to be exported under the name 3S90E Stil 1. Janes also reported that in the Russian forces it would have a name of 3S90M Smerch, Russian, English translation, Tornado. The Buk M1-2 modernization based on a previous more advanced developmental system referred to as the 9K317 Buk M2 featured new missiles and a new third-generation phased array fire control radar allowing targeting of up to 4 targets while tracking an additional 24. A new radar system with a fire control radar on a 24M extending boom reputedly enabled more accurate targeting of low-altitude planes. This generation of Buk missile systems was stalled due to poor economic conditions after the fall of the Soviet Union. The system was presented as a static display at the 2007 Max Air Show. In October 2007, Russian General Nikolai Frolov, commander of the Russian Ground Forces Air Defense, declared that the army would receive the brand new Buk M3 to replace the Buk M1. He stipulated that the M3 would feature advanced electronic components and enter into service in 2009. The upgraded Buk M3 tailor will have a 7 rollers tracked chassis and 6 missiles in launch tubes. Description: a standard Buk battalion consists of a command vehicle, target acquisition radar, TAR, vehicle, 6 transporter erector launcher and radar, tailor, vehicles and 3 transporter erector launcher, TEL, vehicles. A Buk missile battery consists of 2 tailor and 1 TEL vehicle. The Buk M1-2 tailor uses the GM569 chassis designed and produced by JSC MMZ, Medici. Tailor superstructure is a turret containing the fire control radar at the front and a launcher with 4 ready-to-fire missiles on top. Each tailor is operated by a crew of 4 and is equipped with chemical, biological, radiological, and nuclear, CBRN, protection. The radar fitted to each tailor, referred to as the Fire Dome by NATO, is a monopulse type radar and can begin tracking at the missile's maximum range, 32 km/20 mi, and can track aircraft flying at between 15 m and 22 km, 50 to 72,000 feet, altitudes. It can guide up to 3 missiles against a single target. The 9K37 system supposedly has much better ECCM characteristics, i.e., is more resistant to ECM and jamming, than the 3M9KUB system that it replaces. While the early Buk had a day radar tracking system 9SH38, similar to that used on KUB, TOR, and OSA missile system, its current design can be fitted with a combined optical tracking system with a thermal camera and a laser rangefinder for passive tracking of the target. The 9K37 system can also utilize the same 1S91 straight flush 25 kW G/H band continuous wave radar as the 3M9KUB system. The 9S35 radar of the original Buk tailor uses a mechanical scan of a Cassegrain antenna reflector, where the Buk M2 tailor design used a PESA, for tracking and missile guidance. The 9K37 utilizes the 9S18 tube arm or 9S18M1, which carries the NATO reporting name Snowdrift, Russian, 9C18, dome, target acquisition radar in combination with the 9S35 or 9S35M1 fire dome H/I band tracking and engagement radar which is mounted on each tailor. The Snowdrift target acquisition radar has a maximum detection range of 85 km, 53 miles, and can detect an aircraft flying at 100 meters 330 feet from 35 kilometers, 22 miles, away and even lower flying targets at ranges of around 10 to 20 kilometers, 6 to 12 miles. Snowdrift is mounted on a chassis similar to that of the tailor, as is the command vehicle. The control post which coordinates communications between the surveillance radar, S, and the launchers is able to communicate with up to 6 telephones at once. The tail reload vehicle for the Buk battery resembles the tailor, but instead of a radar they have a crane for the loading of missiles. They are capable of launching missiles directly but require the cooperation of a fire dome, equipped tailor for missile guidance. A reload vehicle can transfer its missiles to a tailor in around 13 minutes and can reload itself from stores in around 15 minutes. Also, the Buk M2 featured a new vehicle-like tailor but with radar atop of a telescopic lift and without missiles, called a Target Acquisition Radar, TAR, 9S36. This vehicle could be used together with 2 telephones 9A316 to attack up to 4 targets, missile guidance in forested or hilly regions. The mobile simulator SAM Buk M2E was shown at MAX 2013. A self-propelled fire simulator installation JMA9A317ET SAM Buk M2E, based on the mobile, is designed for training and evaluating the combat crew in the war environment to detect, capture, lock onto, maintain, and defeat targets. A computer information system fully records all actions of the crew to a black box to allow objective assessment of the consistency of the crew's actions and results. All vehicles of the Buk M1, Buk M1-2, missile system use an Argon 15A computer, as does the Zaslon radar, the first Soviet-made airborne digital computer, designed in 1972 by the Soviet Research Institute of Computer Engineering, NISUFT, currently NII Argon. It is produced at a Kishinev plant originally named 50 Years of the USSR. The vehicles of Buk M2, Buk M2E, missile system use a slightly upgraded version of Argon A15K. This processor is also used in such military systems as Anti-Submarine Defense Corps Shun and SOVA, airborne radars for MiG-31 and MiG-33, mobile tactical missile systems Taka, Oka, and Volga. Currently, Argons are upgraded with the Bajit series of processors by NIIP. Basic missile system specifications. Target acquisition range, by TAR 9S18M1, 9S18M1-1. Range, 140 km, 87 miles. Altitude, 60 meters, 25 km, 197 feet, 15.5 miles. Firing groups in 1 division, up to 6, with 1 command post. Firing groups operating in a sector. 90 degrees in azimuth, 0 to 7 degrees, and 7 to 14 degrees in elevation. 45 degrees in azimuth, 14 to 52 degrees in elevation. Radar mast lifting height, 4 tar 9s 3621 meters. Reloading of 4 missiles by tail from itself, around 15 minutes. Combat readiness time, no more than 5 minutes. Kill probability, by 1 missile 90 to 95%. Target engagement zone. Aircraft. Altitude, 15 meters, 25 kilometers, 50 feet, 15.5 miles. Range, 3 to 42 kilometers, 2 to 26 miles. Tactical ballistic missiles. Altitude, 2.0 to 16 kilometers, 1.2 to 9.9 miles. Range, 3 to 20 kilometers, 1.9 to 12.4 miles. Sea targets, up to 25 kilometers, 16 miles. Land targets, up to 15 kilometers, 9.3 miles. Chance to destroy aircraft 0,7-0,93 maneuvering the aircraft 0.6, for 1 missile 9M38. In 92, the system has proven the ability to destroy Scud missile R-17 and rocket MLRS caliber of 0.3 meters. Operation. The Buk is a mobile, radar-guided surface-to-air missile, SAM, missile system with all 4 main components: acquisition and targeting radars, a command element, missile launchers, and a logistics element mounted on tracked vehicles. This allows the system to move with other military forces and relocate to make it a more difficult target to find than a fixed SAM system. The acquisition radar component, several variants have differing capabilities, allows the system to identify, track and target selected targets. The command component is intended to discern friendly military aircraft from foes, IFF, prioritize multiple targets, and pass radar targeting information to the missile launchers. The missile launcher component can carry a variety of missiles, as listed below, and may be able to engage more than one target simultaneously. The logistics component carries additional, reload, missiles and provides other supplies and parts for the system and the operators. In general, the system identifies potential targets, radar, selects a particular target, command, fires a missile, launcher, at the target, and resupplies the system, logistics. The missiles require a radar lock to initially steer the missile to the target until the missile's onboard radar system takes over to provide final course corrections. A proximity fuse aboard the missile determines when it will detonate, creating an expanding fragmentation pattern of missile components and warhead to intercept and destroy the target. A proximity fuse improves the probability of kill given the missile and target closure rates, which can be more than 3,000 km per hour, 1,900 miles per hour, or more than 900 m/s, 3,000 feet/s. Alternatively, the command component may be able to remotely detonate the missile, or the onboard contact fuse will cause the warhead to detonate. The most capable radar, assuming it has a line of sight, no terrain between the radar and the target, can track targets, depending on size, as low as 30 meters 98 feet and as far as 140 kilometers, 87 miles. The most capable missile can hit targets as far as 50 kilometers, 31 miles, and more than 24,000 meters 79,000 feet in altitude. Since the introduction of the Buk in the 1970s, the capabilities of its system components have evolved, which has led to different nomenclature and nicknames for the components' variants. The Buk has also been adapted for use on naval vessels. Integration with higher-level command posts. The basic command post of the Buk missile system is 9510, 9K317 Buk M2, 9S470 M1-2, 9K37 M1-2 Buk M1-2, and 9S470, Buk M1, vehicles, organizing the Buk system into a battery. It is capable of linking with various higher-level command posts, HLCPs. As an option, with the use of HLCP, the Buk missile system may be controlled by an upper-level command post system 9S52 Polyana D4, integrating it with S300V/S300VM into an air defense brigade. Also, it may be controlled by an upper-level command post system 73 and 6Me by call 1Me together with 1 to 4 units of PPRUM1, PPRUM1-2, integrating it with SA-19 Grizen, 9K22 Tunguska, 6 to 24 units total, into an air defense brigade, as well as SA-10/20 and SA-5 Gammon and SA-2 Guideline and SA-3 Goa and Air Force. With the use of the Mobile Command Center Ranzer or Ranzer-M, CROW designations 9S737, 9S737, the Buk missile system allows creation of mixed groups of air defense forces, including Tor, Tunguska, Strela 10, and Igla. Senas is another optional command post for a free mixing of any systems. In addition to mixing their potential, each of the air defense system with the aid of Senas can become part of another air defense system, missile/radar/targeting information. And do not lose quality. The system works automatically. But for the full realization of all functions, a Senas control system need various other monitoring systems for air defense and air force. Otherwise a Senas system will work as a command center, but not within a free association. 3S90 Uragan/M22. The 3S90 Uragan, Russian, Hurricane, is the naval variant of the 9K37 Buk and has the NATO reporting name Gadfly and US DOD designation SAN7, it also carries the designation M22. The export version of this system is known as Shtil, Russian, Stil. The 938 missiles from the 9K37 Buk are also used on the 3S90 Uragan. The launch system is different, with missiles being loaded vertically onto a single-arm trainable launcher. This launcher is replenished from an underdeck magazine with a 24-round capacity. Loading takes 12 seconds to accomplish. The Uragan utilizes the MR750 top steer D/E band as a target acquisition radar, naval analog of the 9S18 or 9S18M1, which has a maximum detection range of 300 kilometers, 190 miles, depending on the variant. The radar performing the role of the 9S35, the 3R90 front dome H/I band tracking and engagement radar with a maximum range of 30 kilometers, 19 miles. The Uragan underwent trials from 1974 aboard the Project 61 destroyer PROV Orny, prior to being introduced aboard the Project 956 Sovremenny class, with the first of class commissioned in 1980. The Uragan was officially adopted for service in 1983. 3S90S. The modernized version of the 3S90M is the 9K37M1-2, or 9K317E, which carries the NATO reporting name Grizzly or SAN12 and the export designation Shtil. It uses the new 9M317 missile. In 1997, India signed a contract for the 3 Project 1135.6 frigates with Shtil. Later, when the decision was made to modernize it with a new package of hardware and missiles, the name changed to Shtil 1. 3S90M Shtil 1. In 2004, the first demonstration module of the new 9M317Me missile was presented by Dolgoprudny Scientific and Production Plant for the upgraded 3S90M Shtil 1 naval missile system, jointly with Altair. Designed primarily for the export purpose, its latest variant used a vertical launch missile which is fired from underdeck silos clustered into groups of 12, 24 or 36. The first Shtil 1 systems were installed into ships exported to India and China. Old systems Uragan, and Shtil could be upgraded to Shtil 1 by replacing the launcher module inside the ship. The reaction time is 5 to 10 seconds, Shtil 1. The interval between starts is less 2 seconds. To protect against boats, helicopters, aircraft, anti-ship missiles. Missiles. 938 and 938M1 missile. The 9M38 uses a single-stage X-wing design without any detachable parts. Its exterior design is similar to the American Tartar and Standard surface-to-air missile series, which led to the half-serious nickname of Standard Ski. The design had to conform to strict naval dimension limitations, allowing the missile to be adapted for the M22 SAM system in the Soviet Navy. Each missile is 5.55 meters 18.2 feet long, weighs 690 kilograms, 1,520 pounds, and carries a relatively large 70 kilograms, 150 pounds, warhead which is triggered by a radar proximity fuse. In the forward compartment of the missile, a semi-active homing radar head, 9E50, Russian, 950, 9501, autopilot equipment, power source and warhead are located. The homing method chosen was proportional navigation. Some elements of the missile were compatible with the KUB's 3M9, for example, its forward compartment diameter, 33 centimeters, which was less than the rear compartment diameter. The 9M38 surface-to-air missile utilizes a two-mode solid-fuel rocket engine with total burn time of about 15 seconds, the combustion chamber is reinforced by metal. For the purpose of reducing the centering dispersion while in flight, the combustion chamber is located close to the center of the missile and includes a longer gas pipe. The 9M38 is capable of readiness without inspection for at least 10 years of service. The missile is delivered to the Army in the 9Ya-266, 9266, transport container. The 938M1 missile uses active homing when approaching the goal. 9M317 missile. The 9M317 missile was developed as a common missile for the Russian Ground Forces Air Defense Forces, PVO, using Buk M1-2, as well as for ship-based PVO of the Russian Navy, S. Its exterior design bears a resemblance to the Vimpel R-37 air-to-air missile. The unified multifunctional 9M317, export designation 9M317E, can be used to engage aerodynamic, ballistic, above water and radio contrast targets from both land and sea. Examples of targets include tactical ballistic missiles, strategic cruise missiles, anti-ship missiles, tactical, strategic and army aircraft and helicopters. It was designed by OJSC Dolgoprudny Scientific Production Plant, DNPP. The maximum engageable target speed was 1200 mph and it can tolerate an acceleration overload of 24 g. It was first used with Buk M1-2 system of the land forces and the Stil 1 system of the naval forces. In comparison with 9M38M1, the 9M317 has a larger defeat area, which is up to 45 km of range and 25 km of altitude and of lateral parameter, and a larger target classification. Externally, the 9M317 differs from the 9M38M1 by a smaller wing chord. It uses the inertial correction control system with semi-active radar homing, utilizing the proportional navigation, PN, targeting method. The semi-active missile homing radar head, used in 9E420, Russian, 9420, as well as 9E50M1 for the 9M38M1 missile, 9E50 for 9M38, and 1SB4 for KUB missile, Russian, 14, was designed by MNII Agate, Zhukovsky, and manufactured by MMZ at Ayashkarola. The 9M317 missile uses active homing when approaching the goal. 9M317M and 9M317A missile development projects. Currently, several modernized versions are in development, including the 9M317M/9M317Me, and active radar homing, ARH, missile 9M317A/9M317Me. The lead developer, NIIP, reported the testing of the 9M317A missile within Buk M1-2A OKRV's code, Sprout in English, in 2005. The range is reported as being up to 50 kilometers, 31 miles, maximum altitude around 25 kilometers, 82,000 feet, and maximum target speed around Mach 4. The weight of the missile has increased slightly to 720 kilograms, 1,587 pounds. The missile's VSCO development program for the Buk M1-2A was completed in 2011. This missile could increase the survival capability and firing performance of the Buk M1-2A using its ability to hit targets over the horizon. In 2011, Dolgoprudny NPP completed preliminary trials of the new autonomous target missile system OKR PANSN, PANSNES in English, developed from earlier missiles. 9M317Me missile. The weight of the missile is 581 kilograms, including the 62 kilograms blast fragmentation warhead initiated by a dual-mode radar proximity fuse. Dimensions of the hull are 5.18 m length, 0.36 m maximum diameter. Range is 2.5 to 32 kilometers in a 3S-90M Stil 1 naval missile system. Altitude of targets from 15 m up to 15 kilometers, and from 10 m to 10 kilometers against other missiles. 9M317Me missiles can be fired at 2-second intervals, while its reaction, readiness, time is up to 10 s. The missile was designed to be single-staged, inertial guidance, radio control mid-course update and terminal semi-active radar homing. The tail surfaces have a span of 0.82 m when deployed after the missile leaves the launch container by a spring mechanism. 4 gas control vanes operating in the motor efflux turn the missile towards the required direction of flight. After the turnover maneuver, they are no longer used and subsequent flight controlled via moving tail surfaces. A dual-mode solid propellant rocket motor provides the missile with a maximum speed of Mach 4.5. Other variants. Original design tree. 9K37-1 Buk 1, first Buk missile system variant accepted into service, incorporating a 9A38 tailor within a 2K12M3 KUB-M3 battery. 9K37 Buk, the completed Buk missile system with all new system components, back compatible with 2K12 KUB. 9K37M1 Buk M1, an improved variant of the original 9K37 which entered into service with the then Soviet Armed Forces. 9K37M1-2 Buk M1-2, gang for export markets, an improved variant of the 9K37M1 Buk M1 which entered into service with the Russian Armed Forces. 9K317 Ural, 9K37M2, initial design of Buk M2 which entered into service with the Russian Armed Forces. 9K317E Buk M2E, revised design for export markets. 9K37M1-2A Buk M1-2A, redesign of Buk M1-2 for the use of 9M317A missile. Buk M2EK, a wheeled variant of Buk M2 on MZKT-6922 chassis exported to Venezuela and Syria. 9K317M Buk M3, 9K37M3, Assam Battalion has 36 target channels in total. Naval version design tree. 3S90/M22 Uragan, SAN-7 Gadfly, naval version of the 9K37 Buk missile system with 9M38/9M38M1 missile. 3S90S, SAN-7B/SAN-12 Grizzly, naval version of the 9K37M1-2 with 9M317 missile. 3S90 Stil, SAN-7C Golem, naval export version of the 9K37M1-2 with 9M317E missile. 3S90E Stil 1, SAN-12 Grizzly, naval export version with 9M317Me missile. 3S90M Smerge, SAN-12 Grizzly, possible naval version with 9M317M missile. Copies. Belarus, in May on the Milix 2005 exposition in Minsk, Belarus presented their own digital upgrade package for early models of 9K37 Buk, called Buk MB. On June 26, 2013 an exported version of Buk MB was displayed on a military parade in Baku. It included the new 80K6M Ukrainian-built radar on an MZKT chassis, instead the old 9S18M1, and the new Russian-built missile 9M317, as in Buk M2. Buk MB has been sold to Azerbaijan. People's Republic of China. HQ-16, Hunky 16, co-developed by China and Russia, believed to be based on either the SA-11 or SA-17. credited with a range of 40 kilometers. Also known as the HQ-16A. HHQ-16, naval variant of the HQ-16 with a range of 35 to 75 kilometers. Li-80, export version of the HQ-16. HQ-16B, improved Chinese development of the HQ-16. Reportedly has improved rocket motor and revised wings, and a range of 70 kilometers. Iran, RAAD, Thunder, medium-ranged surface-to-air missile system using tailor-2 missiles. It has very similar layout to wheeled Buk M2 EK9 M317. It was shown during 2012 military parade. Ukraine, Soviet copies of M1 variants, designed by Artem Arsenal, Kiev, KBS and built in Khaz, Kharkov, and Yuzhmash, Dnepr, plants, planned Dnipro SAM system, between Buk and S300P type. System composition. 9K37 Buk. Upper level CP, PBU of the ZRBR, Zenith Rocket Brigade, from the structure of ASU Polyana D4. 4 times ZRDN, Zenith Rocket Division. CP9S470. SOTS 9S18 Cupole range up to 120 km, 45 km at a height 30 meters. 3 times Zrbut, Zenith Rocket Battery. 2 times Tailor 9310. 1 times Tel 939. Technical Service Division. Communication Service Platoon. 2K12M4 KUB M4, 9K37-1 Buk 1. 1 times SURN 1S91 M3, from the structure of 2K12M3 KUB M3. 4 times Tel 2P25 M3, from the structure of 2K12M3 KUB M3. 1 times Tailor 9A38, from the structure of 9K37 Buk. 9K37 M1 Buk M1, Ganges. Technical Service Division. 9V95 M1E, mobile automatized control and test station vehicle based on a ZIL 131 with a trailer. 9V883, 9V884, 9V894, repair and technical service vehicles based on Ural 43203-1012. 9V881E, technical service workshop based on Ural 43203-1012. 9T229, transporter vehicle for 8 missiles or 6 containers with missiles based on a KRAZ-255. 9T31M, auto crane. MTOATG M1, technical service workshop based on ZIL 131. Preparing to fight, inversely, 5 minutes translation in battle mode, not for the first time in battle, after moving to another place, no more than 20 seconds. During the exercise, Defense 92, 1992, SAM family of Buk conducted successful firing at targets on the basis of ballistic missile R-17 Elbrus, and on the basis of MLRS rockets Smerch, caliber 0.3 meters. 9K37 M1-2 Buk M1-2, Ural. A command post vehicle 9S470 M1-2 may take control over 4 batteries. Each has one Tailor 9A310 M1-2 with 1 times Tel 9A39 M1/9A39 M1-2 or 2 batteries. Each has one target acquisition radar 9S1811 and 2X telephones 9A39 M1. Additionally, the Tailor 9A310 M1-2 may take control over the KUB vehicles, just the Tel 2P25 or the self-propelled unit of reconnaissance and guidance 1S91 with a Tel 2P25. In this configuration, complex can simultaneously fire 2 goals instead of 1. Probability of hitting of 1 rocket is, statically flying aircraft, 0.7 to 0.9, maneuvering aircraft with overdrive to 7 to 8 G, 0.5 to 0.7, tactical ballistic missiles, 0.5 to 0.7, anti-radar missiles, 0.6 to 0.8, cruise missiles, 0.6 to 0.8. The composition, Command Post 9S 470 M1-26 self-propelled fire units 9A310 M1-2 can perform all combat functions, including identification of the state of the owner of the object detected. 3 launchers, can fire, transporting, and loading of other launchers, installation 9A39 M1, target detection station 9S18 M1, machine of maintenance 9V881 M1-2 with caravan zip 9T456, workshop of maintenance SPA M1, machine of repair and maintenance. The maximum range of fire against ballistic missiles is 20 km, and the maximum target speed is 1200 m/s. Its capacity of protecting against ballistic missiles are comparable with that of the Patriot POC-2. However, the engagement ceiling is lower. Preparing to fight, inversely, 5 minutes translation in battle mode, not for the first time in battle, after moving to another place, no more than 20 seconds. The range for engaging targets on land is 15 kilometers, 25 kilometers on the water. The capture distance of targets with RCS equals 5 square meters, 40 kilometers. It automatically provides AH.
Please subscribe and thanks for watching.